this is another thing that I just want to point out because I really think that there's something to the idea of this kind of aristocratic like mindset when this stuff was basically coming about. Maybe not, maybe, but you if you're trying to build something that's kind of like an elite thing, like music, you might come up with symbols that aren't like normal symbols. Like this is kind of something that you might do if you're playing by hand. Obviously, today we possibly would do something that fits in the computer. That's why we would want to do it, because then we can code it easier. But even back then, some of the squiggly lines they come up with and stuff, you're like, that does not seem like it's the easiest thing that you would do, right? It just doesn't seem like it. It seems like something that you might do on purpose to make it weird, right? But what we end up with today is, of course, when I'm trying to put this in the computer, I could just simply copy and paste that little symbol and copy and paste it. But what I'd like to do, of course, is come up with a symbol that is easily typable in the computer, that's not weird. I want a normal coding system, not because I'm trying to change everything, but just because that makes it accessible and easily computed, easily looked at, so I can focus my attention on music creation and not on the weirdness. Now, again, I know a lot of people, I'm not trying to put down like the tradition, like the tradition aspect of it. That's how it's always been done. It looks this way. I like the aesthetics of it. I get it. I mean, that's not my thing. That's not how I usually, but there is some of that that's reasonable. But from a systems perspective, that's what I'm going to keep on looking at, right? So then you've got the E, and then you go from E to F, you get that natural half step, which again is really only there because we had the C major scale first, which I'll talk about in a second. And then we get to F sharp or B flat, depending on if you're going up or down or what you're spelling. And then you get to G, and then finally G sharp or A flat. Why is it G sharp or A flat? Because there's only up to G sharp, and then it goes back around to A. Now, this is the other thing that we want to kind of keep in mind here, is that the actual system is looking like this. We looked at this in a prior presentation, and notice this was created by AI, so it doesn't line up perfect, but this is the idea. We looked up in a prior presentation that in reality, what we have is a system that, like the number line, goes up infinitely, goes down infinitely in a line, but also repeats octave-wise. So visually, in a 3D format, you have a circular pattern like a clock, but also linear direction that it goes infinitely up or down. We can't visualize that, not just you, not just me. I don't think Einstein can visualize this, right, consistently. What he can visualize himself riding next to a light wave, but not that. I don't know. But I don't know what Einstein can do. Maybe he could. But most of us have to visualize one or the other, linear or in a circle. So you can imagine if I keep on going linearly, I would keep on going up this way. It would start over to A, but now I'm in a different octave of A. Now, again, I'm not really thinking I'm in a different octave. I'm just thinking pitch-wise, it's going kind of around in a circle, but it's repeating. But in reality, like number-wise, if we measure it, we're going up in octaves, right, directionally. So now we go back to A, and then A sharp, and it repeats, B, and so on, and we have the same kind of issue up here. So oh man, what did I do? So I've repeated it 2 times here. I want to delete that without it doing something funny. So I've repeated it 2 times here because that allows us to start on any note and apply the same pattern. All right, so there we have that. Now notice you can also, here it is in a circular pattern. So here's the A, B, B, C, C, D, and you can see it in a circle, and it just repeats. This way it's more like a clock format. I put the C on top because we're going to see it in the key of C. So you can see, again, obviously this numbering system is clearly not, from a system standpoint, what you would want to build the system on. You don't want to build a system on a set of numbers that are all just simply equally spaced numbers, but then you created two names for the same exact thing all over the place, right? And when you start, and even these names aren't even constant all the time, because sometimes when you're naming something, you might call it like a B sharp or a C flat, even though we're saying there's not a natural B sharp or C flat. So you get all this weird stuff that's happening, which is crazy because that's like the baseline of your system. Everything is built on the 12 notes. And we've decided that the 12 notes are now going to have multiple names. That's madness, right? That's like there's no way that the pros can outweigh the cons of just having a numbering system. And again, I just want, like, obviously if you just count out the system, I can't even count it alphabetically upwards. I can't even say A, B, C, D, E, F, G because the sharps and flats are there. Now you might say, well, yeah, but you can do that on each of the scales. Isn't that cool? I can do each of the scales have A, B, C, D, E, F, G on all scales built off of all the notes. And it's like, yeah, well, that's cool until you realize that, well, then you have to memorize the number of sharps and flats, possibly by using the circle of fifths, and then you got to know where the sharps and flats lie on it. And sometimes you're going to sharp and flat even the notes that don't actually naturally have a sharp or a flat, like the B sharp and the C flat, because you don't want to have two B's or two. That's, see, that the, no, no, that something is wrong with that, right? So so it's pretty clear that, and also you can't measure distance, obviously. So I can't measure, I can't just say, well, if I go from C down to A, how many half steps is that? We're in a system of half steps. These are all equally apart. They're all apart in equal distance. So I don't want it, but I can't, so you would think I would be able to say, if this was, I can number it. If this is a 4 minus the 1, I can get a distance of 3. But I can't really do that here. Even with simple distance going in an upward direction, I'm going to have to use my fingers to count up. And when I count up, I have to remember the sharps and flats. And when I'm counting backwards, I've got to remember the flats instead of the sharps, right? And if you count backwards, it's even worse. Just try counting the alphabet backwards, just from G to A. And answer me this: is it easier to do that or to count from 7 down to 1? It's a lot easier with numbers. Now, and then add the sharps and flats in there. So now you have to add a flat and then know where the natural half step is, because they happen to put the natural half step on the key of C, right? It's madness that's the way, that's how you're trying to think when you're trying to measure a distance, that's the way you're thinking, right? So again, we can't really remove that, but we can clearly add numbers. We can clearly say, I'm going to add some numbering system. Now, how should the numbering system be based? You might say it should start at 0. If you're a coder, that's probably what you would do. And I'm sympathetic to that argument. Maybe that would be a better way to go, because you get this off by 1 system. I'm putting a 1. Why? Because I think it's just easier for normal people to say that the A is a 1. Now, notice the reason 0 might be used is because if you have a numbering system like a clock, then the clock starts at 0. And when you're going around in a circle, you want to count the distance from each node in the system, each point on the clock head, right? And then go back to 0. That's how you normally would do it if you're putting it in a code system. But like I said, to me, I've mapped the whole thing out and I don't really see a problem doing it this way. I do see that off by 1 issue when we start to get into scales and scale degrees. That's where I'm going to put it. But I can see the argument that you might say, if someone has a reason, maybe you can have a reason why that should be 0 and show me how it messes something important up. I'm not seeing it messing anything important up. And I think it's more intuitive to say that the A is the 1, although it gets thrown off right away because you would think B would be 2 if it was going to line up with the alphabet, and it's not because of the sharps and flats. Now, the other argument is you could say, well, C should be 1 or should be 0. The top of the clock head should be C. Now, why would it be C? Because that seems to be the key that historically we have picked. Why did we historically pick it? Who knows? That's just what they could have picked A, but they picked C. Okay, so C, so we should count it from C. So if C was the key that they historically picked, why didn't they call it A? I don't know. Again, plug it into ChatGTP. Maybe there's some rationale, but I'm sure It's not because they were picking the best system having all of the current information and knowledge, right? So there's an argument that you could make the C one. But again, I think that's less intuitive if you're trying to give a numbering system that most people can see most clearly, right? I would think it would be easiest to start at 1A, that's why. But whatever the numbering system, notice how much cleaner the numbering system is. If I say the notes are 1 through 12, I know that they're all equal distances away. One note to another note is a half step. Half steps are like inches to us Americans, at least we don't have the metric system so much. And that's our standard unit of measure we can think, and there's 12 of them, so there's 12 equal inches. They're all the same. So that removes all this stuff that's actually incorrect of, well, the natural notes, the key of C major is somehow special or different. Those notes, or there's a natural half step between B and C. No, there's no natural half step between 3 and 4. It's the same distance. It's the same distance, right? So the only reason, so then we will apply the formula and derive from these 12 notes using a formula the key of C. But we can derive the same formula starting at any other note and come up with a scale that's just as valid theoretically as the scale of the key of C. So you can see, like, if you're starting the system from scratch, what would you do? I have 12 units of measure, right? I have 12 equal things that are all an equal distance apart, which we call a half step. That's what we would want the baseline to be. It's just unquestionable, I feel like. And again, plug it into ChatGPT, plug it into anything, any kind of software. I think it's just unquestionable, right? So, and then we would want to basically build on that. Okay, so that means that we can't really get rid of the old system, right? Because that's still how we're going to visualize things. But you can certainly, as you're learning, add the numbering system on top of it, allowing yourself to code switch between the numbers and the letters, which gives you the capacity to do simple math, such as, what if we're on C going from A? The distance is 4 minus 1, or 3 half steps away. 1, 2, 3. 3 half steps away from the A. What if I'm going from 3 to 7? What if I'm going from the B to the D sharp, right? Well, I can take 7 minus 3, 4 steps away. 1, 2, 3, 4. Do I count the 3 when I measure distance? No, which is a problem that comes up later when we do scales. They want to make this like the 1. No, you count after the 3, right? And I want to keep on reiterating this because this is the other problem we're going to run into. The scales are renaming as though we have to count this as the 1 in order to count from it, in order to measure distance, right? That's weird. That again, this is my analogy I'm going to keep on coming back to. You have a basketball hoop that's 10 feet high. You have a kid that's 3 feet tall. You're trying to find the distance from the kid to the top of the basketball hoop, but you measure from the kid's chin, and you say, well, if I say that his head is foot number 1, it's 8 feet to get to the top of the basketball hoop. So it's like, no, it's not 8 feet. You don't count his head as you count from the top of his head. From the top of his head. You measure from there, right? And we'll run into that kind of problem when we get into scales. And I think it's just unrefutable that is weird to do. Okay, so then if we have this, notice what I would like to do then is say, look, I don't want these funny sharp, if I'm putting this into a computer code system, and remember, you might say, well, I'm not doing computer code. I play guitar as a musician. I'm not talking computer code. Well, yes, but notice that if the computer, like this is the thing that just drives me crazy. Like, it's like, this is how we're going to learn it. We're going to learn it this way. But when I plug it into the computer, I'm going to give the computer this numbering system. So what are we telling the computer? We're telling the computer, hey, look, computer, I'm going to let you do it the easy way with just a numbering system of 12 numbers so that you can give me the answer